Hey everyone, Carl Carpenter here with Arrakis Consulting. As I promised other people, I said I'd make some videos relating to various technical things, and we're starting at the bottom of the barrel, which is we're gonna be talking about the OSI model today. This video is not designed to be an in-depth video on the OSI model, just super high level. There will be separate videos for each layer of the OSI model. I really didn't feel like it would be appropriate to just cram everything into one video session and then see how easy it is for you to stay awake over time. I say that because the OSI model is not necessarily something that you're going to be able to go to a bar and try to pick somebody up and say, explain how awesome you know the OSI model. It's just not that exciting. However, it is extremely critical that you understand the OSI model if you have anything to do with IT, and that includes all the way up to leadership management and things like that, simply because it's involved in every single aspect of IT. There's nothing around IT or networking or cybersecurity or hacking that the OSI model doesn't have some sort of involvement with. Now, before we before we actually dig into it, I do want to point out that the OSI model is composed of 7 layers. I assume everybody by now knows that. However, you will hear some people say there's actually layers above the OSI model, 7-layer OSI model, like geographical, political, financial, things like that. In some respects, they are correct because a lot of IT kind of depends on the politics of the company you're with, the financial situations, things like that, or maybe the geographical locations. You could even include cultural in there. However, that's also incorrect. As it relates to the OSI model in the traditional sense, there's only 7 layers. There's always only going to be 7 layers, and that's kind of the way it is. There's also a 4-layer model that the Department of Defense uses that we will not talk about in this video, but there will be a video specifically talking about that. That is kind of important to know. If you're seeking certification, then in practically anything nowadays, you have to know the OSI model like the back of your hand. Especially if you're going to do anything with networking or cybersecurity, they do expect you to know the OSI model. From my standpoint, the network layer, the 3rd layer from the bottom, is the coolest layer that there is, closely followed by the transport layer, but that's just me. I'm a little biased because I'm a network engineer and so on as well. All right, so let's dig into it and just start talking about the high level stuff for the OSI model. So the OSI model was developed by the International Standards Organization, or ISO. So if you've ever heard of ISO 9000, ISO 27001, things like that, that's all the same. It's the same organization that develops all of that. The idea behind the OSI model is that they wanted to have a basic foundation that all IT devices, all networks, things like that could communicate with each other in such a way that it really didn't matter who the manufacturer of the various products were. So for example, if somebody developed a new FTP program, they didn't want to have to worry about how FTP was going to work physically over the wire or over Wi-Fi. Or was it going to be with an IP4 address, or was it going to be with an IP6 address? Was it going to be with a DNS name? They didn't want to worry about that. What they wanted to do is have a situation where somebody who's writing FTP software could write the FTP software, because that's what they're good at, and then pass the requests and commands from the FTP software down the model in such a way that it still worked. And then on the same side, companies who made network interface cards, NICs, or network cards, however you want to say them. Although I do despise when people say a NIC card, because that sort of means network interface card. Anyways, the people who make network cards, they didn't want to have to worry about how FTP software was going to work or how email was going to work. All they want to do is be concerned about networking and making sure the network card worked and it could communicate with another device in some way. So basic foundation is the key thing here. It is composed of 7 layers. I've said that a lot, and we'll go over those layers in a minute. Each layer is independent of all the other layers. So what that means is when we get into the different layers, the first layer, the very bottom layer, which is the physical layer, only has to care about communicating with the layer it's directly connected to, which is, if we go to layer 2, that's the data link layer. So the physical layer only has to care about connecting to the data link layer accurately, does not have to care about connecting to the network layer. And now on a different way of looking at it, the network layer, which is the third layer, only has to care about connecting to the data link layer and the transport layer, the layer that's directly below it and the layer that's directly above it. The network layer doesn't have to care about the presentation layer, which is several layers above the network layer. So each layer only has to care about the layers that it's directly connected to and not anything else. All right, so there are other protocols. I did mention that there's a Department of Defense model. It maps, the DoD model is a 4-layer model, but it does map directly to the 7-layer OSI model. So my suggestion is don't learn the DoD model, learn the OSI model, and then I'll teach you a little thing to remember. I call it 3112. That's the mapping of the DoD model to the 7-layer model. So the top layer on the DoD model maps to the first 3 layers starting at the top in the OSI model, and then there's a 1-to-1 mapping, and then another 1-to-1 mapping, and then the bottom 2 layers of the OSI model map to the bottom layer of the DoD model. So if you can remember, if you can learn the OSI model and then remember 3112, then you already know the DoD model. You just have to use a little common sense because the naming's just slightly off. So, but not that bad. So why do we need the OSI model? Primary reason is it makes troubleshooting easier. So if you, let's say you're a LAN tech or a tech in general, and a user is complaining, hey, the printer's not working. Okay, a smart LAN tech right off the bat is going to ask questions like, is there paper in it? Is it turned on? Well, that is it turned on part is the physical layer. Does it have power? Does it have the ability? Is it on? Obviously, the next layer is the data link layer. But if it's not turned on, then obviously it's not going to be working. So a smart tech is going to figure out, is something turned on first before they go around trying to reload drivers or look at print queues or anything else. They're just going to simply try to figure out, is the device turned on? So in a way, that's using the OSI model as a form of troubleshooting. Same thing with networking. If a person says, hey, I can't get on the internet. Well, before the tech goes and starts reloading network card drivers or maybe wiping and loading the computer, obviously a good smart tech is going to say, well, is the cable plugged in? Is there a problem with the cable? If it's wireless, are they on the SSID? Things like that. So again, that's using common sense troubleshooting, but that is in alignment with one of the concepts of the OSI model. I will also point out, if you're studying for your CCNA or CompTIA Network Plus or things like that, there's a high probability making troubleshooting easier is going to be a good answer on a question somewhere. High probability of that. Not saying it's going to be there, but high probability. All right. The OSI model also allows for networks and networking to grow faster. A good example of that is Ethernet. Back in the day, Ethernet was 10 megs, and then we, improved over time, and then it became 100 megs, and then we became gigabit, and now there's 10 gigabit, and there's even faster. We didn't really have to rebuild the entire network to do that. In some cases, we just had to replace the network card, but not the wiring, not the cabling. We didn't have to reformat the computers. In other cases, maybe if you had old school Cat 5 and you wanted to go faster, you might have to rerun cable to go with Cat 6. But again, in that case, all you had to do was replace the network card and run cable. So the idea behind, one of the other ideas behind the OSI model is it allows networking in general, to grow faster and easier. You didn't have to reformat the servers when you wanted to go to gigabit. You didn't have to reload computers, rebuild your entire network. All you had to do was make one small minor change in a few different areas. It also clarifies the general function. So each layer has a function to it, and specifically that function and nothing else. So when you're, again, trying to troubleshoot, or when you're trying to worry or troubleshoot IP addresses or things like that, well, if you're looking at IP address problems, that's the network layer, because that's where IP addresses live. You wouldn't look at the presentation layer for IP address issues or trying to understand IP addressing. It also allows networking to be more manageable and easier to understand and troubleshoot. And obviously, I kind of hit that a lot right now as the troubleshooting standpoint. So networks can be complex, especially the larger networks that have multiple types of topologies like Metro, Ethernet, fiber, microwave, wireless. Adding all that together can get overloading for a few times. If you're adding in MPLS, trying to figure out how it's going to go from one place to another with all the MPLS switches that you have in there. And because we have each layer of the OSI model performing a specific function and nothing else, then it makes the interfacing between the different layers easier to deal with. Because each layer of the OSI model only has to care about what's above and below it. So it makes it easier to go from one layer to the other. And as developers only have to change one layer. So if they want to make an addition or an improvement or something like that, they don't have to rebuild the whole thing. It goes back into troubleshooting and reducing complexity. If we need to make a change to the OSI model to a specific layer, fine, then we just make change to one specific layer of the OSI model, and we leave the rest of it alone. So there are a lot of good things in relation to that. And there's the it also allows if a manufacturer, again going back to the network card, allows for a mastery of one layer of the OSI model. And again, going back to network cards, network card manufacturers don't care what's happening at the presentation layer. They care what's happening at the network layer, the data link layer, the transport layer, and do they have the right interface for the physical layer? That's from a manufacturing standpoint. So it allows for more specialization. All right, there are 7 layers of the OSI model, and this is the order or the layers that you see. The application layers at the very top. I want to point out this is not, and I will go over this again, this is not where the operating system resides. A lot of people, for some reason, think that the application layer is where the operating system resides. It does not. Below that, we have the presentation layer, then we have the session layer, transport, network, data link, and physical. And there are some acronyms or terms you can remember. I always recommend the bottom one. Please do not throw sausage pizza away, because I view the OSI model from the bottom up. That's the way I've done it for decades. It works for me. If you want to remember the OSI model from the top down, that's totally fine. Just remember, it's all people seem to need data processing. In the end, though, it's whatever's good for you and how and how you're going to remember it. But it's entirely up to you on your personal preference. I prefer, please do not throw sausage pizza away. I don't know, maybe I'm a little biased because I guess you're starting at the bottom and it's closer to the network layer. And I'm a networker, so there we go. All right, so let's talk about the general functions of each layer. Starting at the top is the application layer, and that provides the user interface. Again, this is not where the operating system resides. The application layer, if you want to try to get an understanding of what the application layer is, view that as any protocol that is also a command. So for example, FTP is a protocol, but it's also a command you can type in the command line. Telnet, SMTP, um, what are the other ones? FTP is the big one. SSH, that's a good one. All of that those are commands, but they're also found as a protocol. So that's a good way of remembering what the application layer is. We also have the presentation layer. Presents data, handles processing like encryption or data conversion. Encryption in relation to the presentation layer would be important to understand if you're studying for your CCNA or Network Plus, Security Plus, things like that. Another good way of remembering the presentation layer is anything that you can see or hear. So MOV files, MP4 files, MP3 files, GIF, JPEG, things like that. That's a good way of remembering that as well. You'll find certain file types are found at certain layers. All right, then we have the session layers, keeps application data separate from other applications. What I mean by that, let's say you have you're on a file server, and you open up a Word document on your file server, wherever your file server is at. You open up a Word document. That's a session to the file server for that Word document. Well, then let's say later on, you open up at the same time, you open up a PowerPoint document on the same file server. That would be two separate sessions because you have application data from Word, that's in one session, and then you have application data in PowerPoint, that's in another session. Now let's also say that that file server is also your email server. Don't do that in real life, but let's just pretend. If you had Outlook open and getting your email, and your email was stored on the file server, then that's another session. So every single application that makes a connection to multiple locations or a singular location, those would be different sessions. You can also have multiple sessions, but to different destinations. Still sessions, though. All right, then we have the transport layer. That's reliable, unreliable delivery, and I'm specifically talking about TCP or UDP. TCP is reliable because when you send data, if it's by TCP, you're expecting an acknowledgement that the data was received. UDP is the opposite. UDP is when you send data, you hope they got it, but if they didn't, oh well, then they can either ask for it again and you can send it again or whatever. All right, then we have the coolest layer of all, the network layer. This provides logical addressing. This is where your IP addresses are, whether it's IP4, IP6, it doesn't matter, it's right there. This also allows for route selection. So there's two types of packets that are found at the network layer. There's data packets like email, opening Word documents, PowerPoint documents, things like that. And then there's route packets. So when routers talk to one another, they send routing packets from one router to another router to update routes or maybe do a health check, things like that. Below that, we have the data link layer. This is where your MAC addresses resides. Now, some of these layers, while there's 7 layers in the OSI model, some of these layers actually have sublayers to them. And the data link layer is one of those sublayers. And when we get into each layer, which will be a separate video again, when we get into each layer, the data link layer has 2 sublayers to it, the LLC or logical link control and the MAC, media access control sublayer. So if somebody was to ask you on a test, say for example, which sublayer of the OSI model are MAC addresses found, you'd want to say the media access control sublayer of the data link layer because that's where they're at. I also coincidentally like to use that as a not necessarily a trick question when I interview people, but I like to use it so I know the level of experience they have with the OSI model when I say where are MAC addresses found, and I'll give them the whole 7 layers, and you'd be surprised the number of people that are applying for positions that have no clue where IP addresses are found or where MAC addresses are found. In fact, side story, I remember a CISSP at one point. He wanted all this responsibility and authority and stuff like that, but he was clearly over his head. I simply asked this CISSP where our IP address is found in the OSI model. He did not know. Needless to say, he did not get what he wanted. All right, then below the data link layer, we have the physical layer. And that's when, that's the connection between the device with the network. And it could be wireless, it could be with a cable, you know, all sorts of options. But that's the layer that moves the ones and zeros from point A to point B. So once it gets to the physical layer, it's ones and zeros. And as it goes up the OSI model, it actually, those ones and zeros start to come together, and they form a different naming, a different name for the collection of how they come together, or not how, but what they are when they come together. So here's an example of how the OSI model comes together in general. So let's say we have Bob over here, right here on the left. He wants to send an email to Julie over here on the right. So he creates an email, and then he presses send. So as it goes down through the OSI model, it will be broken up into smaller and smaller chunks. So we have one email at the very top, and as it goes down through the OSI model, it will get broken into smaller and smaller chunks. So we have that email, it goes down, he presses send, it goes down, it's data, hits the transport layer, now it's a segment, hits the network layer, now it's a packet. So we've taken that email and we've broken up into a lot more smaller chunks. And the larger the email, the more chunks you're going to get. Then it gets down to the data link layer where it's a frame, hits the physical layer, it's now ones and zeros, and then it crosses over whatever medium, like wireless, like Wi-Fi or Ethernet or fiber, doesn't really matter. And then it goes up to the other side, to the other computer. I think her name, what I call her, Susie or Julie, whatever. And then the exact opposite happens. The small little ones and zeros, they turn into frames when it hits the data link layer. And then as it goes up, it becomes a packet, then it becomes segments, then back to data. And then Julie or Susie, or whatever name I gave her, turns into the email that Bob sent to her. This process happens regardless of what it is. So same thing, if Bob is opening a Word document file over here, and over here on the right side, that's a server, it's the exact same process. If he wants to save or send a Word doc file or whatever, it's the exact same process through the OSI model. It doesn't change just because it's an email versus opening a PowerPoint file or Word document file or anything else along those lines. And with that, I just definitely want to thank everybody. Again, there will be a video for every single layer. And then there'll also be another video explaining the Department of Defense model. When we do get into the every single layer videos, those will be very detailed. So, be sure you have coffee for that. And with that, I would like to thank everybody for being here today. And please subscribe to the channel. It's in the bottom right-hand corner. Talk to you guys later. See ya.